In the last video, we explored cloud databases and how they enable businesses to ingest and use high volumes of transactional data. Let's now discuss the second type of data storage system in the cloud, data warehouses. While databases store transactional data in an online fashion, data warehouses assemble data from multiple sources, including databases. Databases are built and optimized to enable ingesting large amounts of data from many different sources efficiently. However, data warehouses are built to enable rapid analysis of large and multidimensional datasets. For example, a dataset may capture every online sale every day of the week. But if you want to analyze those sales to identify trends, or even to get the sum of total sales each day, you need a data warehouse. Perhaps you also want to identify sales trends by combining data, such as new product rollout dates, marketing campaign language, and operational efficiency data. Think of the data warehouse as the central hub for all business data. Different types of data can be transformed and consolidated into the warehouse, so they're useful for analysis. In particular, a cloud data warehouse allows businesses to consolidate data that is structured and semi-structured. Remember that unstructured data tends to be unorganized and qualitative. In other words, it wouldn't fit in a spreadsheet. When combined with connector tools, data warehouses can transform unstructured data into semi-structured data that can be used for analysis. Let's look at an example. Consider the online hotel booking example we examined in the previous video. Suppose they now want to do even more with their data. They want to use multiple types and sources of data to gain insights about hotel quality and ultimately to improve their service to customers. They identify a list of possible data sources from their end-to-end customer journey, such as number of bookings by type of room, number of guests, and time of year. Overall satisfaction during their stay and satisfaction with hotel staff, amenities, food, and check-in and check-out processes. Customer posts on social media platforms by sentiment, location, or specific event at the hotel. And customer feedback and complaints captured via the website, mail, or in person at the customer service desk. All these different data types and formats are ingested and assembled into a data warehouse through different channels. The business can query the data warehouse quickly and at scale to derive meaningful insights. They can take their business's goal one step further and use the source data to build machine learning models to surface personalized hotel recommendations and tailored booking experiences for customers. We'll talk more about that in the next module. For now, let's look at a Google Cloud leading data warehouse solution, BigQuery. BigQuery is a fully managed data warehouse with downtime-free upgrades and maintenance and seamless scaling. Most of all, BigQuery allows you to analyze petabytes of data using incredibly fast speeds and zero operational overhead. This means that as an organization, you can focus on analyzing your data to find meaningful insights instead of spending time and resources on maintenance. Most data warehouse providers link storage and compute together. So customers are charged for compute capacity, whether they're running a query or not. Importantly, BigQuery is serverless. This doesn't mean that there's no server. It means that resources such as compute power are automatically provisioned behind the scenes as needed to run your queries. So businesses do not pay for compute power unless they're actually running a query. Ocado is one of the world's largest online-only grocery retailer. It experienced significant growth in its early years of business. As a result, it began to find that its old databases just weren't fast enough to meet business demands. Now they've migrated to Google Cloud and use BigQuery. They found that query results are delivered 80 times faster and at 30% less costs. Let's look at another example. Bueno is a software as a service, or SaaS company, that helps businesses meet their sustainability goals by improving building systems. Buildings are usually equipped with various networks that control and operate the facilities they contain. But air conditioning, lighting, and security systems often exist in their own silos with no link between them for communication. Bueno aims to bridge this gap by using technology to gather data and provide better transparency between the different systems so that the building sector can use this information for fault detection, optimization, and business intelligence. Bueno has used cloud technology from the beginning. They decided to migrate to Google Cloud for a range of reasons, one being that they wanted to use existing data to better understand their customers and their business. They do this using BigQuery. There are two other tools they use, PubSub and Dataflow. PubSub is a service for real-time ingestion of data, whereas Dataflow is a service for large-scale processing of data. Remember how I described data warehouses as the central hub for data to flow into? Well, these two different services, PubSub and Dataflow, can work together to bring unstructured data into the cloud and transform it into semi-structured data. This transformed data can then be sent directly from Dataflow to BigQuery, where it becomes immediately available for analysis. These tools enable Bueno to unlock new insights about their customers, such as equipment and site-level data, weather data, and even the customer's last visits. Now customers can use Bueno's system to look for insights and discover new things that may require action being taken. Their customers can generate a work order for maintenance to be done and log the cost of the job. Bueno can then use that data to verify the value and accuracy of their analytics. Now that you understand the differences between data warehouses and databases and have learned about a few Google Cloud services, let's briefly explain how unstructured data can be stored in data lakes.